share the screen.
Mister, can I go to the bathroom before the period starts?
Yes, you can. Yeah.
Okay.
Okay, just a minute because the file is lagging. Don't know why. There.
Good morning, sir.
Hello, good morning. So just 1 minute in order your friends to join and also for the file to open because still we have only 13. They are 26, I think.
Mister, are you sharing your screen now?
No, I'm not. Okay, just 1 minute. Yes. Okay, I'm opening from my mobile. Just understanding my laptop. Please just wait 1 minute. Okay.
Okay.
Okay, sir.
Okay, can you see the share screen now?
Yes, Ustad.
That'd be great.
Yes,
So, sorry for being late because of this lagging and the PowerPoint. So, today our lesson is about defining stoichiometry. Okay, so it's a new idea. We'll talk about it in this week and in this chapter even. The focus question will be what can you learn from balanced chemical equation? If you remember, if we have a chemical equation, we should balance it. We should put uh, and numbers before the chemical formulas. What do you call them? Do you remember? The number, for example, below we call it subscript. What do we call the number before that we put it before a chemical formula of a certain compound? Who can answer? Hello? Raise
yes,
your hand
yes,
if
mister.
you, raise your hand if you want to answer. Okay, no one? طيب I will start asking Ahmed Musa. Hello, good morning. Ahmed.
Yes, mister.
Okay, what do we call this number that is written before the chemical formula of a certain compound in a balanced chemical reaction?
Subscript?
No, no, not subscript, the one before. Hello?
I don't know, sir.
Okay, search for it. Yusuf, yes.
Mr. Is it coefficient?
Very good, excellent. Thank you, Yusuf. So it's coefficient. If you remember, okay, if we have a chemical reaction, we put coefficients before the chemical compound. Like for example, if you have CO2, before it you write 2. So 2 CO2. So it means I have 2 molecules of carbon dioxide. Or let's say H2O. I have 5 H2O. So 5 that is before H2O is called a coefficient. So coefficient is the number that is written before a chemical compound to balance the chemical equation. So, okay, so we learned before about the balanced chemical equation. If you remember in grade 7, okay, you took about the chemical equation and how we balance it. We said before the number of atoms before, in the reactants, should be equal to the number of atoms after. Okay, so the new vocab we learned today about stoichiometry and mole ratio. First of all, we should know what is the name or the definition of the reactant. What is a reactant? Usually in a chemical reaction, we have reactants and we have products. Reactant is the starting substance in a chemical reaction. So the starting substance in a chemical reaction, we call it a reactant. Okay, so let me first share the whiteboard with you. Okay, sorry for this. I will start again presenting with the screen, but just a minute. Okay. So the reactants, as we said, they are the um, just a minute, please. Okay. So I want to share with you the screen again. Okay, so as we said, reactants are the start and the substance in a chemical reaction. Let's say we have okay, C2H6 plus O2 gives CO2 plus H2O. Okay, so this is a chemical reaction. We call it combustion if you remember. Okay, we call it combustion if you remember. Okay, here these we call them the reactants. Why do we call them the reactants? Because they are the element or the substance that I started with. I started my chemical reaction with. Okay, and the products here, these are the products. Why do we call them the products? Because they are the substances that are produced after the end of the chemical reaction. Okay, so the reactants, sorry, this is reactants. Okay, so the reactant, it's the substance that I start the chemical reaction with, and the products are the chemical compounds that are formed at the end of the chemical reaction. Okay, this is just a revision. So we will continue our presentation. So particles and mole relationship, you should know that chemical reactions stop when one of the reactants is used. Yeah, for example, for example, let's say in this equation, look, C2H6 plus O2 gives CO2 plus H2. Let's say oxygen is in the least amount. The amount of oxygen is less than the amount of C2H6. So if oxygen, okay, is almost done, there is no more oxygen, okay, so the reaction will stop. Okay, so if one of the reactants, okay, we have no more of them, so the reaction will stop. So again, okay, we said that chemical reactions will stop. When will stop? When one of the reactants is used up. So when oxygen is used up, the reaction will stop. Or if C2H6 is used up, also the reaction will stop. So not both of them should be used up. One of them is used up, so the reaction will stop directly. So if you want to define the term stoichiometry, please concentrate on this. What do you mean by stoichiometry? Stoichiometry is a study. Study of what? Study of quantitative relationship. Quantitative, it means that we relate on, or we depend on quantity. Okay, quantitative relationship. Between what and what? Between the amount of reactants used. So concentrate, it's a study, okay, which study a quantity relation, quantitative relation between what? Between the amounts of reactants used and what? And the amounts of products formed by a chemical reaction. So this is stoichiometry. Stoichiometry studied the quantities relationship between the reactants that are used and the products that are formed in a chemical reaction. So stoichiometry is based on the law of conservation of mass. You know the law of conservation of mass. Who can let me remember what do you mean by law of conservation of mass? Raise your hand if you have an answer. The law of conservation of mass. Hello? طيب, I will ask other than Yusuf. Yusuf, you just asked. Okay, Muhammad Hadiyan. Muhammad.
Hello, Mr.
Hello. Okay, can you define the law of conservation of mass?
Yes, Mr. So first, I should know, Mr. that the mass, it cannot be created or destroyed. Okay.
Excellent.
Okay. But also.
What about the mass and the mass of the products and the mass of the reactants?
Yes, they should start and end with the same amount.
Very good. So the mass of the reactants should be equal to the mass of the products.
Yes, to the product.
Yeah. So very good. Thank you, Muhammad Hadi. So as your friend said, okay, according to the law of conservation of mass, mass is conserved. It's neither created nor destroyed. Okay, and the mass before a chemical reaction equal mass after, or we can say the mass of the reactants equal the mass of the products. So stoichiometry depends on this law. So there is a relation, a direct relation between stoichiometry and what? And the law of conservation of mass. Why? Because stoichiometry depends on any quantitative relationship between reactants and products, and the mass is one of the quantities that is related between reactants and products. So stoichiometry is based also on the law of conservation of mass. So by this law, the total mass of the reactants equal the mass of the products. You know this from the previous year, also from grade 7. So this is, we call it the law of conservation of mass. So let me please repeat here what we took in this slide, very important. Where, as we said, if one of the chemical reactants is used up, so the chemical reaction will stop. Any one of the reactants is used up, there is no more of this reactant, so the chemical reaction will stop. We said that stoichiometry is a study of what? Of a quantitative relationship between what and what? Between the amounts of reactants used and the amounts of products formed in a chemical reaction. And we said that stoichiometry is related to the law of conservation of mass. As Muhammad Hadi said, law of conservation of mass said that mass is neither created nor destroyed, and the mass of the reactants should be equal to the mass of the products. Any question till here? If you have any, please raise your hand. Any question? Great. So the relationship that can be determined from a balanced chemical equation are summarized in the table below. For example, I have this chemical equation. Look, 4Fe, Fe is iron. S here, it's solid. Okay, don't forget. Look here. Okay, if you see a S in parentheses, this means that we have solid iron. Here, G means gas. If you find L, it's liquid. Okay. So Fe, 4Fe atoms react with the 3 oxygen molecules to give 2 Fe2O3. So here, how many I have? What is the coefficient? It's 4. Here the coefficient is 3. Here the coefficient is 2. So this is a balanced chemical equation. How I know that it's balanced? I will just count the number of atoms before and the number of atoms after. Look, here I have how many? Who can help? Yeah, I will choose one of you. Majdi. Majdi. Hello, Majdi. طيب, where's your microphone, يا Majdi? You don't have a microphone? طيب. Next time, prepare yourself, please. طيب, Karim.
Mr. Majdi's mic doesn't
Hello?
work. It's like that
Yeah,
from
yeah.
last week.
Yeah, I
Hello?
told them. Yes, Karim.
Okay, Mr. Yes.
Okay, how many iron atoms do you have here?
4.
And in the products?
Yeah, 4.
Very good. 2 times 2, it's 4. How many oxygen atoms do we have here? And
We have 6.
6. And in the products?
We have. Wait. I think 6 as well, yes.
Yes, as well, it's 6. So 2 times 3, it's 6.
Yes.
So you multiply by the coefficient by the subscript.
Yes.
Okay, so the number of atoms before equal the numbers of atoms after. Or the number of atoms in the reactants equal to the number of atoms in the products. So we can say this equation is balanced. So in this way we can detect if this chemical equation is balanced or not. Okay, look here. Iron plus oxygen give iron oxide. This is the name. Type. Here if I want to count the atoms, look, 4 atoms of Fe plus 3 molecules of O2, so 4 atoms of Fe plus 3 molecules of O2 gives 2 formula units of Fe2O3. This is a formula unit. Okay? Or I can say it in a different way. I will say 4 moles of Fe plus 3 moles of O2. This is in moles. It will give 2 moles of Fe2O3. So here, this coefficient also represents the number of moles. So 4 moles here, 3 moles here, 2 moles here. So 4, 3, and 2. 4, 3, and 2. Or from the number of moles, okay, I can find the mass. You know moles equal what? From the previous quarter, moles equal what?
Moles equal molar mass.
Moles equal molar mass?
No, Mr. Moles equal mass over molar mass.
Great. Moles equal mass divided by molar. Yeah. Yeah. This is moles. Type mass equal what? Mass equal?
Mass
Yeah.
equal
مول times molar mass.
Very good. Moles time molar mass, exactly. So if you know the number of moles from the so if you have a chemical equation, if I give you this one, you just look at the coefficient. It's 4, so I have 4 moles. So how can I know the mass? I'll just multiply 4 by the molar mass of Fe. You will go to the periodic table, you find the molar mass of Fe, and you multiply it by 4. So you have 232 or 223.4. The same thing for oxygen. You go to find the number of, okay, here we have, sorry, you can find the mass of oxygen, okay, depending on this mass equal multiplied by molar mass. The same thing here, okay. But look here, this is the main idea. 319.4 grams reactants, 319.4 grams products. So what can we deduce from here? Yeah, let's take Faris Omar. Hello, Faris. Also your mic, Faris, please check your mic the next time. طيب طيب عبد الرحمن حسام عبد الرحمن. Hello. طيب وليد. Riyadh.
Yes, Mr.
Walid, you are here. Okay, Walid. So depending on this, what can you deduce? What can you conclude? Here we have 319 grams, and here we have 319.4 grams.
Like, Mr. What, like they are both like Mr. They are both.
Yeah, they are both what? 319.4, 319.4. So they are what?
Like equal to each other. Are
Equal.
balanced.
Very good. This is according to the law of conservation of.
Stoichiometry?
No, law of conservation of mass, which is related to stoichiometry, or stoichiometry related to law of conservation of mass.
Mr.
Okay? Yes.
Abdurrahman told me stick to this. I cannot talk much.
Okay, طيب ماشي. Okay, great, no problem. Okay. طيب. طيب, just a minute now. I will send you now a worksheet to solve, okay, or a quiz or an assignment.
Assignment or worksheet,
Yes.
Mr.
Yes, an assignment. Just a minute, please. I will prepare it in 1 minute, just a minute, and I will send it.
Mister, we solve it now?
Yes, please. You solve the assignment now. I send it to you. You have 4 minutes to solve it.
Mister, if I submit, I can leave.
Yes, mister.
Yes, submit and leave.
Okay, thank you, mister.
Okay, Mr. Thank you. Have a good day.
Have a good day. Bye bye. Okay, please, if you didn't open the assignment yet, please open it and solve it.
Mister, I finished. Bye. Have a nice day.
Okay, bye bye.
Mister, I finished as well.
Okay, you
Bye.
can leave. Submit and leave.
Okay, thank you, Mister. Bye.
Bye bye. Okay, Priscilla, Abdulaziz, Ahmed, and Faisal and Muhammad, please submit your answers.
Good morning, Mr. Hadi.
Good morning, Mr. Ashraf.
Student start to leave?
Yeah, because they have an assignment.
Okay.
They solve it and leave.
Okay, sir. Have a great day, sir.
Thank you. Same for you. Bye bye.
Okay, bye-bye.